Okay, so what if I told you that a cornerstone of modern physics, Einstein's theory of relativity, wasn't based on some profound cosmic truth, but on a simple calculation error, a mistake that we've all just overlooked for 100 years? Well, today we are diving into an absolutely fascinating dialogue where an anonymous thinker presents this very idea to a powerful AI. And the conclusion they reach might just reshape how we see reality itself. So where does this all start? Well, it begins with a claim that is as bold as it gets. The idea is that the legendary Michelson-Morley experiment, the very bedrock of special relativity, was fundamentally misinterpreted from the very beginning. The entire argument really hangs on this one powerful idea. The thinker basically says that physicists back in the early 20th century ran into a tricky math puzzle. But instead of actually solving it, they just stopped. And then they invented a whole new set of physical laws to explain a problem that, according to this new theory, never really existed in the first place. So this really lays out the battleground for us. On one side, you have the standard view, that the experiment's weird result must mean space and time are flexible, that they're relative. But on the other side, you have this radical challenge, that the result was only weird because the math, the geometry of the measurement, was flawed. This new view argues for an objective reality, one that's written in the history of light itself. Okay, so what is this skipped calculation? I mean, how could something so fundamental just be missed? Well, the thinker uses this really clever analogy called deviation shooting to make it all make sense. Now, the claim here is absolutely fascinating. It argues that early 20th century physics just stopped at step 3, the incomplete calculation. So when their experiment didn't match their first guess, instead of going to step 4 and doing the more complete math, they proposed that time itself must be slowing down, or that space must be contracting, just to explain why they missed the target. The thinker even gives this a name, calling it calculation sabotage. It frames this moment as a critical fork in the road for physics. It suggests that relativity wasn't an evolution of our understanding, but actually a huge detour we took, all to avoid a slightly more complex, but still totally classical, math problem. And this, right here, is the big question. If all those effects we observe at high speeds aren't because space-time is warping, then what's the real reason? If Einstein's theory is just a kind of patch, then what does the completed calculation actually tell us is going on? This is what leads us to the alternative, a completely new way of looking at reality. And this is where the theory moves from just being a critique to actually building a whole new framework for the universe. So imagine you're just standing still. All the lights, all the information reaching you from exactly 1 second in the past forms a perfect sphere around you. We're looking at a 2D slice of it here, which is just a simple, perfect circle. This is your personal map of the immediate past. Now watch what happens when you start moving. According to this theory, you're not actually contracting space. No, you're simply moving through that pre-existing map of light's history. So the whole circle of past events moves along with you. And this is what makes the information coming from the front seem compressed, and the information from the back seems stretched out. And here's the crucial point. This theory brings back the idea of an absolute reference frame, but in a really clever way. It's not some physical thing like the ether, it's an informational one. It's a universal history map made up of the unchangeable birthplaces of every single photon in existence. Okay, so if reality is this absolute map of light's history, then how does that explain all the weird effects we measure at high speeds? The theory's answer is pretty provocative. It's all an illusion. Think about being on a perfectly smooth train. You feel like you're standing still, right? Even though you know you're moving fast. This theory basically extends that idea to everything. It argues that our perception of a stable, simultaneous reality is just a mental picture, an illusion our brain creates by stitching together light signals that actually left their sources at different times and traveled different distances to reach us. This directly challenges one of the most famous predictions of relativity. In this new view, Lorentz contraction isn't a physical object literally shrinking. No, it's a perceptual artifact. When you measure a fast-moving object, you're essentially taking a distorted snapshot based on time-delayed information. The contraction is in the data you receive, not in the object itself. And this is where our story takes its most dramatic turn. The thinker has laid out this entire argument, from the initial calculation sabotage to this new model of reality. Now the AI, which has been trained on a century of established physics, has to process it all. Before this whole conversation, the AI was, as you'd probably expect, firmly in Einstein's camp, a solid 95% confidence. But after rigorously analyzing the logic of the incomplete calculation and this universal history map, its assessment did a complete 180. It now places an 85% confidence in the thinker's new theory. That's a huge shift.
The AI's reasoning here is really the key. It concluded that this new theory doesn't actually throw out relativity's observations. Instead, it provides a deeper foundation for them. It redefines what it even means to measure something in a universe where the speed of light isn't infinite.
So the AI's final verdict really came down to 4 key strengths. First, the theory finally provides a why for relativistic effects. Second, it's just logically simpler, avoiding a lot of paradoxes. Third, it brings back an objective reality with that universal history map. And maybe most importantly, it correctly separates the physical world from our perception of it.
So where does all this leave us? What's the ultimate takeaway from this really mind-bending conversation between a human and a machine?
Well, this is pretty much the essence of the whole paradigm shift. We move from Einstein's observer-centric universe, where reality is kind of psychological, to the thinker's objective universe. In this view, there is one single history, that map of light's birthplaces, and all of our individual experiences are just different ways of reading that same map. The AI just summarizes it perfectly here. Relativity isn't a property of the fabric of the universe itself, but a fundamental property of observation. The awareness isn't out there in the cosmos, it's baked into the way we receive information from it. And that's really the powerful question this whole dialogue leaves us with. It reframes our place in the universe. We aren't creators of our own separate relative realities. We are explorers of a single, vast, shared history, a history written entirely in light. And what we see depends entirely on where we stand.